Hi everybody, happy Monday. We're gonna go through our last lesson in Unit 10. We're still talking about special right triangles, but we're talking about the other case, which is a 30, 60, 90 special right triangle. And in order to come up with the formulas for this specific triangle, I'm gonna start with an equilateral triangle, which means all the sides are the same. Remember when we covered equilateral triangles are also equiangular, which means all of these angles are 60 degrees. And this angle would be 60 as well. But that doesn't give me a 30, 60, 90 triangle. It gives me a 60, 60, 60 triangle. So in order to start building a 30, 60, 90, I'm gonna add a segment to this, and I'm gonna drop, this is called an altitude, which means that it's gonna form a right angle with this other third side. So I have a 60-degree angle, a 90-degree angle, and using triangle sum theorem, these angles up top would be 30. And if you add them together, you get 60, which gives you the original angle in the equilateral triangle. But this is good because now if I look at like one of these triangles, like specifically the one on the right, this is now a 30, 60, 90 special right triangle. So now we're gonna start to talk about the side lengths. So what I'm gonna do is let this leg of the right triangle be x. Now, this triangle on the right and this triangle on the left are congruent to one another because of hypotenuse leg. So if they're congruent, this would also be x. So what is the side length of each side in the equilateral triangle? Well, x plus x is 2x. So all of these sides in the original equilateral triangle would be 2x units long. Now, this 2x in the 30, 60, 90 is across from the right angle. So this is the hypotenuse. Now, in a 30, 60, 90, we have two legs. But in a 45, 45, 90, both of the legs happen to be the same length. That's not the case in a 30, 60, 90. We have a short leg and a long leg. The short leg is always going to be across from the smaller angle, which is 30 degrees. So this is the short leg. The long leg is then going to be across from the 60-degree angle, which is this altitude that I drew in. So I'm going to label that Y, and I'm just going to abbreviate LL for long leg. And with this triangle on the right, I'm going to set up Pythagorean theorem. So one leg, the short leg, is x, so the leg squared, plus the other leg, the long leg squared, which is y, equals the hypotenuse squared, which is going to be 2x. I'm going to simplify 2x squared, so 2x times 2x would give me 4x squared. I want to solve for y here. That's my goal. So I want to solve for y. So I have to get this x squared to the other side. So I'm going to do that by subtraction. And then I don't want y squared, I just want y. So I'm going to have to take the square root. Now, there's two terms here basically under the radical in this expression. There's a 3, which is not a perfect square, and there's an x squared, which is a perfect square. So I'm going to take the square root of x squared, which would give me x, but 3 is not a perfect square, so I'm going to leave that under the radical. Now, why is this important? Again, this formula is going to work every single time we have a 30, 60, 90 special right triangle. But what does it mean? So remember when we started off the problem, the long leg was y. I'm going to abbreviate long leg with LL. The short leg was x. I'm going to abbreviate short leg with SL. And then we have a root 3. So this formula is super important. So on this first slide, I definitely want you to copy this formula down. It says that the long leg in a 30, 60, 90 special right triangle is always equal to the short leg times the square root of 3. We're going to have one more formula though, because this formula says nothing about the hypotenuse. So if we go back, the hypotenuse was 2x and the short leg was x. Well, how do we get from x to 2x? We have to multiply by 2. So the other formula is going to be a little bit easier. The other formula is if we double the short leg length, so if we take x and we multiply it by 2, we get the hypotenuse. So in your notes, you definitely want to have down these two formulas that are boxed because we're going to be using them for the entire note sheet for today. Just to fill this in, the ratio of the sides in a 30, 60, 90 special right triangle, it's 1 to 3 to, root 3 to 2. So the long leg is the short leg times root 3, and then the hypotenuse is the short leg times 2. But again, like the most important thing to have down from this first slide are these two formulas I have in the box. So for the next examples, we want to find some missing side lengths. So I have a 30, 60, 90 special right triangle. There are two side lengths missing. So I'm just going to give them some variables. And what I'm going to do now is go through the 30, 60, 90 triangle and label the hypotenuse, the short leg, and the long leg. I recommend doing that to help you with these problems. So the hypotenuse is across from the 90-degree angle. So 18 is the hypotenuse. The short leg is always across from the 30-degree angle. So 30 degrees, we look across. Here I wrote X, so this is the short leg. The long leg is always across from 60 degrees. So 60 degrees, we look across. Here's the long leg. And then for every problem that I do also, I'm going to start by writing these formulas down. And then if I've labeled my triangle and I've written down the formulas, all that's left to do is to substitute. So look in the picture, find long leg. Long leg was Y. Look in the picture, find short leg. Short leg was X. Well, because I have two variables here at the moment, I can't do anything with this one. So let's move to the next one. So I have 2 times, what was the short leg? It was X. What's the hypotenuse length? That's 18. So I have 2x equals 18, which we can solve for x. X would be 9. So our short leg is 9. Well, over here we need the short leg. We need x, which was 9. So I'm going to take 9, which was x, and sub it in right here. Y was the long leg that we needed to find. So again, these formulas are like shortcuts. So it really wasn't too much work to solve each of these for x and for y. So y was our long leg, it's equal to 9 times the square root of 3. X was our short leg, it's equal to 9. Again, one more example like this. So I'm going to go through and first just label, like I have this angle would be 30, 60, 90. I have 2 missing side lengths, so I'm going to go ahead and label them X and Y. And then I'm going to go ahead and label the hypotenuse, the short leg, and the long leg, which I can find across from the 90-degree angle, the 30, and the 60-degree angle. So across from 90 would be the hypotenuse. across from 30 would be the short leg, SL, and across from 60 would be the long leg, LL. And again, I'm going to go ahead and write down the two formulas. Oops, equals. And then I'm going to go ahead and fill them in from the picture. So what was the long leg? The long leg was 5. What's the short leg? That's x. Times the square root of 3. So I can solve this for x. Remember, we're multiplying here. So what undoes multiplication? That's division. So I'm going to divide each side by the square root of 3. So over here I have x, which is great. That's what I want. Now, remember in my last video I talked about how it's like bad formatting in math to leave a radical under the denominator or in the denominator. So we do a process called rationalizing the denominator, which means you are going to multiply the top and the bottom by the radical. In this case, it's not root 2 anymore. When we had our 45, 45, 90, yes, in the bottom it was root 2, but now look, it's root 3. So I'm going to multiply top and bottom by root 3. So up top, I have 5 times the square root of 3. Usually we write the number outside the radical first. That's why I'm flipping the order. And then in the bottom, we have root 3 times root 3, which means we just have a 3. That's equal to x. Now, because 5 is not evenly divisible by 3, I'm not going to go ahead and simplify this. If this were like a 6, well, 6 is divisible by 3, so I would go ahead and simplify it. Since it's not evenly divisible, I'm just going to stop there. So again, x was our short leg, so we just figured out the short leg is 5 times the square root of 3 over 3. So now, when I go over here, I know that 2 times the short leg, which was x, but I just found x to be all this. So I'm going to take this and replace it in for the short leg. So I'm going to multiply 2 over 1. I have a fraction over here, which is why I'm putting this over 1. Times 5 times the square root of 3 over 3. And that's going to be equal to the hypotenuse, which is y. So when we multiply fractions, we multiply up top and in the bottom. So I'm going to multiply the numbers that are like terms that are outside of the radical. So that's 2 times 5, which is 10. But then we have a root 3. And in the bottom, we have 1 times 3, which is 3. Because 10 is not evenly divisible by 3, I'm going to stop there. These can get a little bit tricky just because you have a lot of like radical work you need to do. So the next one, I want to find the length of CD. So I have 2 right triangles, 2 30, 60, 90 special right triangles adjacent to one another. The only side length I'm given is 9 times the square root of 6. I need to find CD, which is all the way over here in this triangle. So the first thing that I'm probably going to want to do is find the length of BD because it's the only length, it's the only side shared by this triangle and this one. So I'm going to start in this 30, 60, 90 special right triangle where if I look across from 60 degrees, I have the long leg, and x is what I want to find, and in this triangle, it is the short leg. So that formula, long leg equals short leg times root 3, is what I'm going to want to use over here to find x. So the long leg is 9 times the square root of 6. Short leg is x, and then I have root 3. So I want to divide by root 3. Now, you could rationalize here, but there's a little shortcut. Notice that we have a radical up top and a radical on the bottom. So they're kind of like terms. 6 in the radical is divisible by 3, which is in the radical. Because they're both in the radical, you can simplify them with division. So this is going to be equal to, what's 6 divided by 3? It's 2. But it has to stay in the radical because 6 and 3 were in the radical. And then we have a 9 out in front. So that's what x is equal to. I'm just going to redraw this triangle over here. I just found what x was, what BD was, and it was 9 times the square root of 2. I need to find the length of CD. Maybe I'll label that a y. But now in this triangle, 9 times the square root of 2 is across from 60 degrees. So this is my long leg. I want to find y, which is the hypotenuse. And then in order to do that, the common factor between both of the formulas with long leg and hypotenuse is the short leg, which I don't know right now. So I have to find that short leg. So I'm going to start with the first formula. The long leg is 9 times the square root of 2. The short leg I just labeled as z to use a different value. I'm going to divide by root 3. Now, 2 is not evenly divisible by 3, so I'm not going to use this shortcut over here. I am going to rationalize. So up top, I have root 3 times root 2. Those are the like terms. So under the radical, 3 times 2 is going to give me 6. Out in front, I still have that 9. Well, what's root 3 times root 3 in the bottom? That's 3. And then outside the radical, we do have 2 numbers that can be simplified. 9 divided by 3 is 3 times the square root of 6. That's what z was. Our whole goal, though, is to find the hypotenuse. So the second formula is what I need to use here. So the short leg we just found to be 3 times the square root of 6. We're going to multiply the like terms, which are the terms outside the radical. And then we have a root 6. So again, this one was a little bit tricky because we had so much radical work to do. And if we're not used to those radicals, which has probably been a little while since we've done that in Algebra 1, we just need a little bit of a refresher on it, that's all. Now, we have one more problem to do. This problem was a copy and paste error, so you could just cross that out if you printed out the notes. So, the last problem here is we need to find the length of BC. Again, we have 2 right triangles adjacent to one another. The difference in this one is that one of the triangles is a 45, 45, 90, and the other one is a 30, 60, 90. So, again, my goal is going to be in this problem to find the common side length first. Because if I know a 2 over here and I eventually want to get into this triangle, BD is the only thing that's shared by the 2 triangles. So that's why I want to start by finding that. So we're first working in a 45, 45, 90 triangle. What was the formula from the other day? It was the leg times the square root of 2 equals the hypotenuse. Again, we're dealing with a 45, 45, 90 over here. The hypotenuse is 2 and the leg is x. So I'm going to again divide by root 2. But we need to rationalize. So up top, I have 2 times the square root of 2. In the bottom, I have 2. Again, I can simplify. 2 divided by 2 is just 1. So this is really just going to simplify to root 2. So this is root 2. So in the 30, 60, 90, root 2 is the short leg. I need to find BC, which is across from the 90-degree angle, and that's the hypotenuse. So the formula with the short leg and the hypotenuse is probably the one I'm going to want to use here. The short leg is root 2. The hypotenuse I just labeled a y, and then once we sub that in, we get our answer for the value of y. And again, we're not doing that last problem because we already did that in our last set of notes.